Hi guys, welcome to another episode related with the conversion of your boat into a hybrid or full electric boat. Remember that in previous episode I explained the procedure to remove the gasoline or diesel engines and replace the gas or diesel engine for that electric motor. And that system was solved. In this moment the unit is running with a DC motor. I replaced a diesel engine 4-cylinder for this Quite Torque 10.0 electric motor. That motor required at the input 48 volts DC. 48 volts DC entering here, and 3 phases are going out to provide power for the electric motor. And the system is running well, and the system is exactly the same that any conversion that you want to do in a sailboat, in a small power boat. This is the process. In other episodes I explained the criteria to calculate the motor, the criteria to select the battery bank, the procedure to do the wiring. Today I am focused in the process to provide power to the inverter charger, the AC power coming in and the AC power coming out to the AC panel. In previous episode I talked about the galvanic isolator, the process to install the galvanic isolator. This is another episode. Today we are going to talk about the power coming in from the shore power and the power coming in from the generator. This is why I install in this particular case an automatic transfer switch. And the automatic transfer switch have 2 options: on top for shore power and in the bottom for generator. And this is the signal that we are going to connect here, hot and neutral, and this is the signal for the relay in order to activate the remote AC panel contactor. In this particular case, in this project, I don't have a contactor in the main panel. I have a regular breaker. I don't have a contactor. But if in your RV or in your boat you have a contactor, it's simple, because the signal to activate this contactor in the main breaker will be coming here from the common and normally open, because this is a contactor with a normally open signal AC coming from this point. Okay, if the shore power is connected, immediately the automatic transfer switch allows that the current coming from the shore power enter in the AC panel and activate the contactor, the main breaker for the AC panel. Or if the shore power is off and the generator provide power, the generator immediately send the signal and activate the contactor. Yes, this is the contactor that normally is located in the AC panel, the main breaker of the AC panel. In this particular case, in this particular project, we don't have a contactor. We have a shore power coming in, generator power coming here, and in the back, the power coming out enter directly here in the AC coming in, AC power coming in. In this particular case, we are going to talk about the connection of the automatic transfer switch. The automatic transfer switch receive power from the shore power or receive power from the generator. Receive power from the generator, and the generator is connected in the breaker. Okay, this is power coming in from generator, and this is power coming in from shore power. And the automatic transfer switch in this moment is in the position manual, will be located in automatic if the transfer switch decide which power is coming in. Okay, this connection, this is the neutral and the hot, coming from the shore power connection, and this is the connection normally open, common, and normally closed. This is the connection to activate the breaker. If I have in the AC panel, the main breaker, a contactor like this, the contactor receives the signal for the contactor here from the normally open connection. and the contactor will activate and the contactor close and the power enter in the AC panel. Exactly the same if the power entering is coming from the generator. The power enter here, neutral here, hotline here, and the signal activate the contactor in the AC panel, and the contactor close the contacts and the power enter in the panel. Okay, in this particular case, we don't have a contactor in the AC panel. In the AC panel, we have a regular breaker, and the breaker is a normal breaker that receives the power from the output of the inverter charger. In this particular case, we have a 48 volts 2025 amps inverter charger Victron Smart. Okay, this is the AC power coming out, connected directly into the AC panel, and this is the AC power coming in. The AC power coming in is coming here from the output of the automatic transfer switch. This is the input generator, this is the input short power, and this is the output. This is the output entering in the AC panel, in the AC in. That's correct. Hot, neutral, and ground. And this is the grounding cable, connected into the bonding conductor, connected to the external sacrificial anode. All right, in this particular case, our automatic transfer switch provide the power to the inverter charger, and the inverter charger to the AC panel, and the AC panel receive the power here in the main breaker. When the main breaker is activated, I have power in the branch breakers. This is the explanation about how the automatic transfer switch should be connected. And the other source of power coming into the inverter charger is the DC power. The DC power, positive and negative, is coming from the links distributor. The link distributor receive power from the solar system, and the solar system is connected with the panels on top. This is the switch for the solar system, power coming in, and this is the power coming out, positive and negative, and this is the power entering in the inverter charger to work in the mode inverter. All right. In other words, the inverter charger will be working with power coming from the short power, with power coming from the generator, or with power produced from a DC power coming from the battery bank entering here, and the inverter convert in AC, and the AC is provided to the AC panel. This is the process to connect the automatic transfer switch, the inverter charger, and the AC panel.